Hi, in this video we're going to look at change in variables. In the first video we saw a simple example of how the rainfall in any given area may depend on many factors. So let's assume someone discovers in a particular area the rainfall is a function of maybe air temperature and ocean currents. Later on, they discover that both the air temperature and the ocean currents depend on their own on two other variables. Perhaps they could be wind speed and land geography. So we can perhaps assess the rate at which rainfall is going to change with respect to air temperature and currents. But would we be able to check how the rainfall will change with respect to wind speed and geography? Well, there is a method to do that, and it's about converting between different variables. So in terms of notation, we would say that z is some function of x and y. However, x is some function of two new variables u and v, and y is also a function of u and v. So how do we now relate our derivatives to be in terms of u and v? So in other words, what we're asking is, how do we get day z, day u, and day z, day v? Okay, well, the answer to that question is to go back to our trusty relation that we have established in the previous videos. That is, delta z is equal to day z, day x times delta x plus day z, day y, delta y. So we divide everything by delta u. So we have delta z divided by delta u equal to day z, day x multiplied by delta x over delta u plus day z, day y times delta y over delta u. And of course, if we extend delta u to approach 0, then all these deltas become d's. So we would get that delta z is equal, or delta z, delta u is equal to day z, day x times day x, day u plus day z, day y times day y, day u. And the same is true of day z, day v. This would equal to day z, day x times day x, day v plus day z, day y times day y, day v. So we can apply this in a very simple example, and that example would be we could have z equal to x squared minus y squared, and x is equal to r cos theta, and y is equal to r sine theta. And our question is asking us to determine day z, day r, as well as day z, day theta. So this example is the same as the relations we have just derived now, except that instead of u and v, we have r and theta. So if we write these relations to be in terms of r and theta, what we would get is day z, day r is equal to day z, day x times day x, day r plus day z, day y times day y, day r. So let's do this first before we go on to theta. So day z, day x, if we look at our equation, we take y as a constant, so that becomes 0. So this is equal to 2x. Then next we look at day x, day r. X is equal to r cos theta. So taking the theta to be a constant, so that remains as is, cos theta will not change. Therefore, we just find the derivative of r, and that would be 1. So our answer here would be cos theta. Doing the same for the second term, day z, day y. X squared, this is a constant, that becomes 0. And the derivative of minus y squared is just minus 2y. So we have minus 2y. And day y, day r, again, this is just going to be sine theta. The r derivative of r is 1. So we can substitute x and y inside this equation. X is equal to r cos theta and y is equal to r sine theta. So we can put these things inside. So that would give us 2 times r cos theta, and we already have a cos theta. So we're going to have cos theta multiplied by cos theta, and that's going to give us cos squared theta. So this becomes 2r cos squared theta. We bring the minus in front, and y is r sine theta. So in the same way, we're going to get r sine squared theta by substituting it in. It becomes minus 2r sine squared theta. So bringing this 2r in front as the common factor, we get 2r into cos squared theta minus sine squared theta. So this does look familiar. What this is, it's equal to cos of 2 theta. This is a double angle formula. So you can check that up in your high school trigonometry if you really want to. So this is going to simplify to 2r cos of 2 theta. The next part of the question to determine day z, day theta, what we would need to do is write the function differential. So that's going to be day z, day x times day x, day theta plus day z, day y multiplied by day y, day theta. So let's just remind ourselves what the function is. Z is equal to x squared minus y squared, and x is equal to r cos theta, and y is equal to r sine theta. So day z, day x is again 2x, and day x, day theta, well, the derivative of cos is minus sine, and r remains as it is because we're treating it as a constant here. So in brackets, we would have minus r sine theta. So the second term, I'll do it on the next line. We're going to have plus. Next is day z, day y. So day z, day y is, well, minus 2y. And day y, day theta, the derivative of sine is cos. We would have r cos theta. So now substituting all of this into this equation, we get 2 multiplied by x, which is r, and we already have an r inside this brackets here. So x is r cos theta, and we're going to be multiplying this by r sine theta. So the r times the r is going to give us r squared, and perhaps we should write the minus here as well. 2r squared sine theta and cos theta. And then the second part of the equation, we have minus 2y, so we'll write the minus again. And y is r sine theta, so we substitute that in. We get minus 2, again, r squared sine theta cos theta. So these two terms are the same, so we can just add them together. So minus 2 is minus 4. So we're left with minus 4 r squared sine theta cos theta. So again, if we remember our double angles, we would remember that sine of 2 theta is equal to 2 sine theta cos theta. So if we now substitute this inside inside our equation, we see that we're left with minus 2 r squared sine of 2 theta. So in this manner, we were able to successfully compute what day z, day r was equal to, as well as day z, day theta. So this was the objective of this video, and we were able to show this through this example.